The most popular form, I think, is the slope-intercept form. And that is your y equals mx plus b. And already the y-intercept here is easy to determine, and that means that your y-intercept b is equal to 8. For the slope, we just choose to find the slope, we just choose any 2 points and use your formula y sub 2, y2 minus y1, or x2 minus x1. And to do this, you could choose any points, any 2 points at all. Since we already have an easy point 0, 8 here, let's try to use this, 10, 3. So the slope using these points would be 3 minus 8 over 10 minus 0. And that's just negative 5 over 10, or negative 1/2. Now, let's say that you chose a different point, or use 2 different points, like say this, 4, 6, and 8, 4. We should get the same answer. Because then that would be 4 minus 6, negative 2, and 8 minus 4 is 2. That will still give you negative 1/2. And so the equation could now be written as y is equal to negative 1/2 x plus 8. But suppose you forgot to simplify negative 5 over 10 and you wrote this as negative 5 over 10x plus 8. That is not incorrect. And the same with negative 2 over 4. Y is equal to negative 2 over 4x plus 8. And naturally, if you use two different points, you might come up with different fractions that will all simplify to negative 1/2. And so there is an infinite number of ways which you can write the equation. So there's an infinite number of ways that you can write the equation using this format, but of course we prefer the one that is simplest. Another form that is commonly used is the Pointslope form, which goes y minus y sub 1 is equal to m times x minus x sub 1. And let's find the equation of this same line that we used earlier using this form. And to use this form, we just need m. And m, we've already seen it as negative 1/2 a while ago, which we got from negative 5 over 10, and also negative 4 over 8. Actually, it could be any fraction that will end up as negative 1/2 when simplified. So to use this form, we just need any point on the line. So because there's an infinite number of points on the line, there's going to be an infinite number of ways to express it. So for example, if we use this point, the x1, y1 there will just be the coordinates of the point. So the equation would be using 0, 8, the equation would be y minus 8 is equal to negative 1/2 x minus 0, which you could just write as y minus 8 is equal to negative 1/2 x. But as you can see here, if you simplify this, you will end up with the same equation that we got earlier, which is 1/2 x plus 8. And if we use this point, the equation would be y minus 6 is equal to negative 1/2 times x minus 4. And again, you will find that if you simplify this, you will come up with this equation. And if we use this, the equation will be y minus 4 is equal to negative 1/2 x minus 8. So this can go on and on and on. So there's an infinite number of ways to express it. And there are other forms, like you have your general form, your standard form, and it turns out there is also a vector form, or there is what we call as the vector equation of a line. The format or the formula for the vector equation of a line is r equals a plus tb. Okay, hold on. Let me rewrite that. Let me write that here. R is equal to TA plus TB, where T is a scalar and R, A, and B are vectors. B is called the direction vector, and it works in a very, very similar way as the slope. In fact, if we rearrange the slope-intercept form, instead of y equals mx plus b, write it as b, y equals b plus, instead of mx, write it as xm. We will find in a bit that b will sort of correspond with a, and m will sort of correspond with the direction vector. Let's start with the similarity between m and b. If you remember, to get m, we choose 2 points and then use the coordinates of those 2 points to find slope using this formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's your slope. The direction vector b is very similar, it's similar because to get the direction vector, you actually also choose any 2 points on the line, and then, but it is a vector, and if you choose any 2 points on the line and get the vector between them, you just get the differences between the coordinates. Only that you start with the x coordinates. The x component will be the difference in the x coordinates, and the y component will be the difference between the y coordinates. So it's very similar. It's sort of just inverted, and the slope is a fraction. The direction vector is a vector. Again, in both cases, whether you're looking for the slope or the direction vector, the process is the same. You will need to choose any 2 points. So let's say, for example, that we are going to use these 2 points to look for both the slope and the direction vector. Let's see the difference. So here, if we are using, I'm going to call it, okay. So if we are using 4, 6, and 8, 4, we have used this earlier. So the slope would be 4 minus 6 over 8 minus 4, which is your negative 2 over 4, or negative 1/2. While here, it is going to be, if we call this as A and this is B, and you want your direction vector to be AB, so if we want our direction vector to be AB, then it will be 4, sorry, we will get the x components first. So it will be 8 minus 4 and 4 minus 6, which is negative 4, sorry, positive 4, negative 2. Okay, actually, you could already use this as your direction vector, but if you simplify this sort of and factor out negative 2, you factor out negative 2 and write it, you could write that as negative 2, 4 divided by negative 2 is negative 2, and this is 1. Then you could use that as your direction vector. B is equal to negative 2, 1. Now look at the similarity between this and this. On the other hand, if you use BA as your direction vector, that would still be valid. And that would just end up with negative 2. This will just end up with negative 2, 4, or, so that can already be your B. Or if you simplify it like we did here, we will end up with a B of negative 1, 2. Oh, sorry, this should be negative 4, 2. Okay, this is, let me change that. This is negative 4, 2, and this is negative 2, 1. So already we have found a few different combinations of components for the direction vector using only 2 points, and this could go, so we have negative 2, 1, 2, negative 1, 4, negative 2, and this can go on and on and on as you choose any 2 points on the line. Now let's talk about A. A is just the position vector of any point on the, so for example, so also because it's any point on the line and there is an infinite number of points on the line, there are an infinite number of possibilities for A. So for example, if I choose this point, let me try start with this point. If I choose 0, 8, then A is the position vector of that point from the origin. So remember that your origin is 0, 0. So the position vector of 0, 8 from the origin would be 0 minus 0 is 0, 8 minus 0 is 8. And another possibility for A, if we choose 4, 6, so that's the position vector. It will be the position vector of that point from the origin. So another possibility for A would be 4 minus 0 is 4, 6 minus 0 is 6. And this could go on and on and on. So with the different possibilities or the different vectors that could be used for A and the different vectors that could be used for A, there's going to be a different ways to write R. So one way would be, say, R is equal to, if we use this and this, that will be 0, 8 plus TB, so negative 2, 1. By the way, because R will have an X and Y component, you could also write this as XY. R is a vector, so it has an X component and a Y component, so it will be XY equals 0, 8 plus T 2, 1. And again, that's just one possibility. Let's try this problem. Find the vector equation of a line that passes through the points 2, 4 and negative 1, 10. So we start by keeping in mind that the formula that we are using is R is equal to A plus TB. For A, because you have 2 points, there are two possibilities for A that we could use. So it would be the position vector of 2, 4. If you use 2, 4, position vector of 2, 4 from the origin will be 2 minus 0 is 2, 4 minus 0 is 4. Or if we use negative 1, 10, the position vector of that point from the origin is negative 1, 10. For B, there's a bunch of different possibilities as well. If I make 2, 4 as A, and I let negative 1, 10 as B, then the vector B, I could use vector AB, and that would be negative 1 minus 2 is negative 3, 10 minus 4 is 6. So that could already be used for B. But if I sort of simplify it and write it as a factorize negative 3, sort of factor out negative 3, so I will have here 1, negative 2, then I could use this as B. So that's sort of the simpler version of negative 3, 6. This is sort of the simpler version of this. Or, as we have done earlier, we could make BA as our direction vector. And again, it will give you another B. But already, we can form at least 4 pairs there, but we only need 1. So one possibility would be R equals, if I use this and let's say this, then that would just be 2, 4 plus T 1, negative 2. And again, that's just one possibility, and because R is a vector, it will have an X component and a Y component, and it will be 2, 4 plus T 1, negative 2. The answer is either this, in this form, or in this form. And again, that's just one possibility.